Okay, hi and welcome to today's chat. Today I'm joined by Mike, and what we're going to do is talk about how we got into computing and some guidance for you on how you might start to troubleshoot and debug different programs. So my name's Rachel, I'm a senior lecturer at the University of Dundee, and I teach basically introduction programming. So I'm the person that you see when you try and figure out what's a variable, what's a for loop, what's a function. So I'm joined today by Mike. Mike, do you want to give us a little bit of background about you?
Of course. So hello, my name is Michael Crabb and I am a lecturer within computing at Dundee. In terms of the modules that I normally teach on, it's currently 2. So I teach on our first year web development course. So this teaches things from HTML to CSS to JavaScript through to using lots of different web development libraries. And then I also teach on our Agile module, which is something that's taken by our third years and also by our master's students. And that's more looking at the project management side of computing and how we as professionals kind of use different skills to make sure that we're understanding how projects all fit together and then how computing actually fits into these things as well.
Yeah, cool. So I want to find out how you got into computing, because I know my kind of journey into finding computing was a bit unconventional. So how about you? Why did you decide computing is what you were going to do?
So, so going back kind of many years ago, my dad used to work at NCR, which is one of the big factories in Dundee. And I still remember maybe when I was about 5 or 6 years old, he brought home a computer for the very first time. So that was back in the days before Windows. The first computer we had just ran DOS, and it didn't even have the small kind of 3.5-inch floppy disks. It had the kind of the big 5.25-inch ones. And he brought home this big computer and then this big pile of games, and then said, "There you go nuts." So I took one of the games, put it in the computer, and fell in love with it straight away. I really liked the idea that this single bit of plastic contained so much entertainment that we could use. Sorry, I'll mention as well, I am working at home and I've got a 2-year-old in the background. So if you do hear bangs or bashes, it's probably him just running around. Yeah. So I really like that. And kind of moving on into primary school, I still had this love of computing there. I was always the one in the classroom that you'd see on the computer in the corner, just kind of playing away, trying to figure out how it worked. Sorry, what was that?
BBC computers on those big trolleys that you used to...
Exactly, yes. So the BBC microcomputers, the one pretty much every single classroom had one. So I remember that, and then kind of going forward into secondary school, I still loved computing. So I did my standard grade in computing, I did my my higher computing, and I did my advanced higher in computing as well. But it wasn't just something for me that was something interesting to do at school. I liked doing things in the home as well with it. I still remember there was one time, maybe when I was in probably S2, so what's that, about 13, 14 years old. We went to Game when it was still a thing as a real store, and we went to it with my parents, and there was all these kind of different things, and I looked at them, I was like, well, I've already got Roller Coaster Tycoon and I've been playing that for a while. I've already got Theme Hospital, I've been playing that. And then there was this big book for, well, how do you make computer games? And I thought, that looks amazing. So I got this book as a 14-year-old kid, having a book about this big that taught me how to make computer games. And I think one of the first things that I made was like an asteroid simulator. So it was one of the ones where you've got the little character along the bottom and everything else kind of flies down and you've got to shoot them. And it was really interesting, even from a young age, kind of learning, well, that's how computer games work and how we make them. And that kind of flowed through. So I did my undergraduate in computing, and then within that discovered more about the people side of things. And then after that went on and did my PhD, and that's how I ended up finally ending up at Dundee.
Yeah, so my first kind of exposure to computers was quite similar, but I had a ZX Spectrum, and I harassed my parents for a long time that this is what I would really like for Christmas. And it came, and I think I played Paperboy for about 5 years, just on the go, because I'm really bad at games, right? So it pretty much took that long for me to be able to do it. So I did that, and then gaming was a nice accessible way to get into it. So I also had one of these big books. Mine was How to Use Visual Basic. So my first real, actually typing code was Visual Basic in high school. again, I was maybe S3 because it was the start of my standard grades, which is like old school Nat 5s or something. And when I did that, I realized that like you can manipulate the images and you can do all this stuff within it. And I remember I made this game and I was really proud of this game, and you had this little car and you could move the car around, but I didn't know anything about object detection or boundary collision or any of these things. So you could drive over the obstacles if you wanted to. Mm-hmm. But I played for hours just maneuvering this car around, imaginary obstacles. It was great.
Yeah, so I think I started even before Visual Basic. So the first language that I used in school was Comal, which is proper line based. So you start off your line like 0, 1, 0, 0, space, print something, 0, 2, 0, 0, space, print something. And the reason that you have lines 100, 200, 300, 400 is because if you ever need to write anything in between, you've got 99 extra lines of things that you can put in between. So I remember using Comal, and then there was a package called Turtle Graphics. So I guess it's kind of, similar to the idea of your kind of car moving around, but it was just this little white dot that you could kind of decide, well, here's the thickness of the line, here's the color of the line, draw whatever shapes you want. So I guess it's really similar to processing and the kind of stuff that you're teaching, but going back many, many, many years ago.
Yeah, I think I missed out that part. Like I missed out the real geek section. I didn't really, I was very much a consumer of technology until probably I hit third year, and I started learning that there were other options when I was doing it at school. I think I went into computing thinking, oh, I'm going to basically make websites. Like that's what I thought was going to happen. Mm-hmm. And then suddenly I wasn't. I'm wondering if you've got any kind of nice memories of learning. Any nice kind of things that you remember of like, type moments when you were learning programming?
So I think the best memory, and it's still something that happens when you're programming, is that you always feel like when you're doing something, you're hitting a brick wall. So if something goes wrong, like you could do an entire page and then there's one little bit will just cause everything to collapse. And you'll sit and work on it for ages and ages and ages. And then eventually you'll figure it out and you'll press compile and it'll all work. And then you'll just sit and think to yourself, I'm a coding god. And this is something that it happens to absolutely everyone, and it's that smile that you see on people's faces when that happens. It's just amazing, because it's part of being a programmer is kind of this trial and error, and part of it is kind of being used to not being able to do something first and then kind of going on and being able to do it afterwards, and it's a really interesting skill to master. But if you get that nailed, then it kind of helps you so much.
But it's so much outside of programming as well, right? It's just resilience. It's building resilience. And I think a lot of people come into studying that they've not really failed before. Mm-hmm. And this is, programming is just repeated failure.
Yeah, exactly. Yeah, I mean, it's something that I'm kind of used to. So I'm currently sitting in my my dining room. If I move my camera around, you can actually see we've got a piano in the corner. So I've played the piano since I was 5 years old. As a 5-year-old, sitting down in front of an instrument and being told, you're going to start off by not knowing anything. And every single time that you open up a piece of music, you're not going to know how to play it. You have to have that resilience in place. And I think kind of knowing that from the offset and working on it helps so much. It's having that blank page and then knowing at the end of it, you're going to have something amazing, but you need to work. It's not just going to appear by itself.
Yeah. And I think that's why I really like processing, actually, because I think sometimes you can learn programming and it's quite dry because the interface doesn't look funky. It doesn't look interesting. There's no immediate I can control this interface. And I think processing gives you that, which is...
Mm-hmm. Yeah, it's exactly the same with web. So one of the things that I love the most about teaching web is that you can go from having a blank page to something quite nice within about 3-4 hours. And first day you can even do it within half an hour. But yeah, you're right. It's exactly the same with processing. The getting started in it and having something really cool after a small amount of time is amazing.
Yeah. So how do you, with the first time you program, right, it's quite intimidating. Like, what's your advice to people when they first sit down and it is blank? That you've got that blank page. How do you overcome that initial?
So I think part of it is, don't go for something that is going to be so difficult that it will put up a big enough block that you won't be able to get through it. So there is no point, if we go back to the music analogy, there's no point in you trying to kind of play a kind of a 60-minute sonata or something the first time you sit down in front of a piano. Do something easy first. Learn Twinkle Twinkle Had a Little Star. If you're doing processing, just learn how to draw a square. If you're doing web development, just learn how to make a simple HTML CV so that you can actually say, well, this is my name, here's my qualifications, blah, blah, blah. And if you get all of that easy stuff done first, think of it as Lego building blocks. The more that you learn these bits, the more you can join them together. And as soon as you join them together, you can make something incredible. I mean, if we think about processing, so if you learn how to draw a circle in processing, great, you've learned how to draw a circle. But if you learn how to draw a circle and then figure out, well, I can take these circles, draw 8 of them at once at slightly different angles, you've now learned how to draw a cloud.
Yeah.
So it's taking that and then building one part onto the next, onto the next, onto the next. And that, I think, is the thing that a lot of people they struggle with, because they might think, right, I'm going to go into this, I'm going to draw a cloud straight away, and then they'll get terrified about how all these angles are going to work together. But if you take it back to first principles and say, okay, let's do these small bits, build them together, it makes life so much easier.
Yeah, it's true, because I remember the first time I ever used Visual Basic, and because that was my first kind of program, right? And I remember being like, oh, I can make all of these things. And I tried to make a calculator, like a visual calculator that you can click. And I tried to just do all the functions at once, right? Rather than being like, oh, I've got 2 numbers and I can add them together and get the answer. That's the basis, and then we'll build on this. And I think it maybe took me a week or so before I was like, no, I'm going to start again. Mm-hmm. But that's my personality, right? I'm just really stubborn. So stubbornly bashing at the door for so long before I realized that actually it's probably as well just letting it go and starting again. Yeah. And that's the hardest part, because by this point you have amassed hundreds of lines of code that effectively do nothing. Mm-hmm. But you're taking all your work and chucking it out the door. Mm. And that's really hard.
Yeah. But that's one of the big things. I mean, it's why the way that we teach programming, the way that we do it, is to have lab activities, then assignments. So go wrong as many times as you want when you're like trying out your lab stuff, because to be fair, it doesn't count. It's a chance for you to experiment. It's a chance for you to play. And I would much rather that someone came to me and said, I've tried all the lab activities, I haven't managed to complete any of them, but I now understand the principles, than someone that says, haven't done the lab activities, but I went straight into the coursework. Here it is, completed. Great, what does it mean? Not sure.
Yeah, or I think the problem I often come across is people who do the lab activities and they just do them. They just, by process of trial and error, I've got what I was supposed to get, mm-hmm. Moving on.
Yeah.
And the thing I always say is like, can you comment every single line of that bit of code that you have and tell mm-hmm. me what it is?
Yeah.
And if you can't do that, you've not finished the lab activity.
Yeah,
because
exactly.
They're not big things in themselves, right? But there's a lot of digging that you can do.
Yeah.
Especially the for loop by for loop one. To get nested for loops to make a grid of boxes.
Oh, okay. Ah, right, yeah.
Nested for loops do whatever, right? Sometimes it's like you draw them and it just counts 4, 5, and then 1, 2, 3, 4, 1, 2, 3, whatever. But the one I have for my processing activities is you draw a line of boxes. That's one for loop. And then you have to turn it into a nested for loop to repeat that line.
Oh, again and again, okay.
And so many people are just like, they try a loop inside a loop and change the number here and the number there, and eventually they get it and they're like, done. And you're like, but how? Well, it's done. Don't know. And then they run away, right? So it's like, yeah, if you can comment every single line, then you're winning.
Yeah.
So, yeah, I want to talk about debugging before time gets away with it. Debugging, I think, is one of the hardest parts for people, especially when you're using something that's visual, like processing or web stuff, processing, because it's got that continual repeating code element, is something that a lot of people get confused by. So how do you approach debugging? Like, what are your strategies and tactics that you use and you teach to figure out what's going wrong with code?
Okay. So there's two main tactics that I use when I'm trying to do debugging. The first of these, so with web dev, there isn't, or especially with JavaScript, there isn't a really good basic debugging console that says, this is what's gone wrong right now. So I rely a lot on actually printing things out into the console myself. And I guess this is something you can do in processing too. So if I'm creating something and I get an outcome that's not what I'm expecting, the first challenge is figuring out, right, well, where has that error occurred? Where is something going wrong? So a simple JavaScript example, let's say I'm trying to get information from a weather website to display the current weather on my website. There's lots of places along that path that something can go wrong. It could be, am I making the correct connection to the weather website in the first place? Am I downloading the right bit of information from that weather website? Am I then parsing that information correctly? Once it's parsed, am I storing it in a variable that's actually going to be able to deal with it? And then is it being displayed in the right place? So there's a little jump between each of these. And the challenge is figuring out, well, which one has gone wrong? So what I would normally do within web dev or within JavaScript, I would, between each of these steps, I would do a little line. So console.log, and then display what I think is going to be happening at that stage. Once you've done that, you can actually look and you'll get this line by line thing that says, okay, well, this is at this point, this is at this point, this is at this point, this is at this point. Doing that is a really good way to then figure out, okay, well, this point here, so let's say it being attached to a variable, is where it's going wrong. And once you've figured that out, it really narrows down what the challenge is, and it makes it a little bit easier for you to say, okay, well, here's where the problem is. What are the different ways that I can solve this? Sure, most of the time that's going to involve you going online, going on places like Stack Overflow, because if you've had a problem, there's a high likelihood that someone else is going to have had a similar problem. So you can look online for resources that might help you. Or it's going to be a case of figuring it out yourself and saying, right, okay, well, have I come across anything like this before? How can I use other techniques that might help me with this? So that's quite a good technique if you've got a linear path for a problem and you've already coded something and you're trying to figure out, okay, well, where is the challenge arising? The other side of it is if you've got a big problem that you're looking at and you don't really know how to do it. So with this, there's lots of different ways that people refer to this. Some people use the term rubber ducking. So what we do with this is you basically just take a rubber duck and you explain the problem to the rubber duck and then take it for a walk. Unfortunately, we're in lockdown and all my rubber ducks are stored in a cupboard on campus, so I don't have any rubber ducks just now, but I do have a 2-year-old son, so if I do have any big issues, then we go for like an hour walk between the fields and I explain to him all of the nice interesting intricacies of JavaScript and TypeScript, and then that normally acts as a nice way. I can't tell you the number of times I've had an issue, went for a walk, then came back to it and went, okay, I now know what it is I've got to do.
But I mean, for students in practical terms, that's turning to the person next to you in the lab and saying, hey, if I explain this, do you understand it?
Yep.
Or what I often find is we spend a lot of time writing code.
Mm-hmm.
How often do we actually read code?
Yeah.
Like, you see when you go out into the world, reading code is the primary thing that you're going to do, right? But until you actually go out there and start working with other people, you don't really read code. So
exactly, yeah. I mean, this is one of the
learning a language by only writing it. When would you ever do that? You wouldn't.
Yeah.
I'm always like, okay, if you have something and it's not working, give it to someone else. What do you think this does? And then they, oh, well, that variable becomes, and you're like, oh no, that variable should not be anywhere near that. Oh, I see, I can change it. And I think, yeah, it's interesting the thing you say about little steps, because in processing, I find people will like try and create this intensive interaction and then press run. Oh, it didn't work. But you have no idea at what stage of that interaction it failed because you didn't test all of them all the way along. So I think that's so important. But yeah, and a diary.
Oh, okay.
diary. So when I did, so my undergrad was something different. I did an MSc conversion course, and the first programming assignment was to keep a diary. And at the time I was like, what is this? Like, come on. And it was so simple. It was just every day you write down what programming did you practice?
Mm-hmm.
What was an error message you got, and how did you fix it?
Mm-hmm.
Or what was a problem you encountered and how did you fix it? So was it like a syntax error or a logical error? And I think learning the difference between those two is really important. And it was like a 3 weeks or something, maybe 2 weeks, and you handed it in, and it was worth like 5 or 10% maybe.
Mm-hmm.
And it was just so valuable because you were forcing yourself every day to reflect on what you were doing. And that kind of reflection was just super valuable. And I think it taught me that skill of taking a step back and looking at the situation.
Yeah, I've never come across that one. That sounds like a really kind of valuable idea.
Because what's interesting is we ask our final year students to do this.
Mm-hmm.
When students are writing a dissertation, we ask them to think critically, reflect on what they've achieved. We ask them to reflect on their processes, blah, blah, blah. And we do that throughout the degree program to an extent, but that's a really big piece of work. And how often have you actually had sufficient practice on self-reflection and that sort of thing? And it's hard to say that you were wrong. So
yeah,
it's nice to kind of understand that you being wrong doesn't make you wrong.
Mm-hmm.
What you did was wrong, or how you solved it was wrong, and it's a whole different level of stuff.
Yeah, I mean, it's one of these things as well. It's so much easier to learn from mistakes than it is to learn from success. So the more times that you're getting things wrong, the more times you're learning, well, this is how it's not going to go wrong in the future.
Yeah.
Yeah, I mean, it would be so easy to say to people things like web development, things like processing, like, sure, go online, copy code from someone else and then put it in, and great, you've managed to achieve something, but you've not learned anything.
No.
And then when someone asks you to do something similar, you're not going to know how to do it. So by actually doing it yourself, making these mistakes, it's what makes you a better coder.
Yeah. It's character building.
Yes.
Okay, right. I'm going to kind of draw us to a close, but before we go, I want to ask you, so if programming students or someone who's learning programming, if they should just remember one thing, what should it be?
Okay. So this is kind of semi-based on my teaching of web development. So within web dev, it's a very kind of big and mixed environment. So you need to know HTML to know how to structure the data. You need to know CSS to know how to make it look nice. You need to know JavaScript in order to make it kind of more interactive. But not only do you need to know JavaScript, if you want to become a proper web developer, people will say, oh, you need to know Angular, you need to know Node, you need to know Vue, you need to know all of these different frameworks. And it can be quite intimidating, especially within computing when we go outside of web dev as well and think, oh, you've got to know C++, you've not got to know Java, you've got to know Python. At the end of the day, though, inside of all of these things, a for loop is a for loop. An if statement is still an if statement. And if you can understand all of these basic things first, when it comes to actually learning a new language or a new library, well, you'll know how to do it because you've got the basics down. So I guess that's my main bit of advice.
Yeah. Which goes back to that kind of, what does that line do?
Yeah, exactly. Yeah.
An understanding of the concepts. Yeah, so I think my summary of today's chat is that you should make mistakes, read code, and buy a rubber duck.
Yes.
That seems sensible. Okay, thank you very much.
Thanks. Bye now.